Hello, Integrated Math 1 students. It's Mrs. Robinson here to work the Practice Benchmark Chapter 1 with you. You can come here if you have questions. You can pause and rewind it and just make sure you know how to do all of these. Okay, the first one says simplify. There is no equation here. This is just an expression. So to simplify, you're going to use distributive property. So you're going to distribute 12 to the 4 and to the negative 8p. So 12 times 4 is 48. And then let's go 12 times negative 8, which is going to be negative 96p. And you're finished with that one. Okay, on to the second one. Once again, this is not an equation. There's no equal sign. It's an expression. So we're just going to simplify. And you can think of this one as also as using the distributive property. We're going to distribute using division. 6 divides into 24k, and 6 divides into negative 18. So 6 times 4 is 24. So if I divide 6 into 24, I'm going to get 4k. If I divide 6 into 18, I'm going to get, negative 18, I'm going to get negative 3. And you're finished with that one. Let's go ahead and look at number 3. This one, in order to simplify, once again, it's not an equation, it's an expression. In order to simplify this one, you want to combine all like terms. And then simplify it into a smaller expression. So careful with your like terms. They need to be exactly alike. PQ, PQ, and PQ. These are all the same exact terms. So I can combine them. If this was a PS, I wouldn't be able to combine them. But they're all PQs, PQs, PQs. So I can combine them. So I have 25 PQs. Plus 13 PQs. So if I do 25 plus 13, I'm going to get, what is that, 25, 35, 36, 38 PQs. Okay, so I've simplified that part. Now I have negative 35 PQs here. So let's write what we have left. We have 38 PQs, and we still have minus 6, minus 35 PQs, plus 4. So I can go ahead and combine the 38 PQs and the negative 35 PQs. So if I take 38 and I subtract off 35 PQs, I'm going to get 3 PQs. That's how many will be left. So I've simplified that part. Now up here I have negative 6 plus 4. Those are just numbers. I can go ahead and combine them. Negative 6 plus 4 is going to give me negative 2. And you're finished. Okay, this one actually is solve each equation or problem. So these are equations. You can see they have equal signs. So let's go ahead and do this. We've got this equation. Now on one side of the equation, I'm going to solve for t. I've got a t here and a t here. So before I start working both sides of the equation, let's simplify just this side like it's an expression. I have 1t minus 4t's, and that's going to give me negative 3t's. I still have plus 10, so I'm going to write that down, and that equals negative 11. Now I've combined all my like terms on this side. I'm going to go ahead and start working both sides. I want to get t by itself. So I'm not going to divide by negative 3 first. I'm going to get rid of this 10 first. So peel off the layers, peel off the extra things first. So I'm going to subtract 10, and I'm going to get negative 3t equals negative 11 minus 10 is going to be negative 21. Now I've got negative 3 is multiplied by t. So to undo multiplication, I do division. So I divide by negative 3. And that's going to give me t equals negative 21 divided by negative 3. And a negative give me a positive. And I'm going to get positive 7. And you're done. All right, number 5, we have an equation. Before we start working both sides of the equal sign, we want to get rid of these parentheses. So we're going to do distributive property just to this side. So I'm going to multiply 5 by 5t, and I'm going to get 25t. And I'm going to multiply 5 by negative 2, and I'm going to get negative 10. So I've simplified this part. I still have my equal sign. I still have negative 35 on this side of the equation. Now let's start working both sides of the equation. I'd like to get t by itself. 25 is multiplied by t, but I know I don't want to do that division first. I want to peel off the layer, so I want to get rid of this first. This is minus 10, so I'm going to do the opposite of minus, which is add. Add 10 to both sides of the equation to keep the balance. And then I'm going to bring down 25t equals negative 35 plus 10. So I have negative 35 and I add 10, I'm going to get negative 25. Now t is over here and it's multiplied by 25, so the opposite of multiplication is division. Divide both sides by 25. That eliminates that. Bring down the t. I'm going to get t equals negative 25 divided by 25 is negative 1. A negative divided by a positive stays negative. And I'm going to get t equals negative 1. And you're finished with that one. Okay, on to this one. There are a couple ways you can approach this one. You've got some fractions down here. I'm going to show you the one way first real quick. In order to get these fractions together and to get the r by itself, I could add 1/5 to both sides of the equation. Okay, and that eliminates the negative 1/5 here. I bring down the 5r, and over here I have 4/5 plus 1/5. Well, 4/5 plus 1/5, they have common denominators, so I add numerators. I get 5/5, and 5 divided by 5 is just 1. So I'm going to get 5r equals 1. Now I'm not finished solving. R is not by itself. 5 is multiplied by r, so to get it by itself, I divide by 5. And then I'm going to get r equals 1/5. And you're finished. Now a second way to do this, if you had a more complicated problem with different denominators, would be to multiply both sides of the equation. If you do it to both sides, it's fine, by the common denominator. And here it happens to be 5 because they are common denominators. So if I multiply both sides of the equation by 5, it's going to get rid of all my denominators. Distributive property. 5 times 5r is 25r. 5 times negative 1/5, we'll write it over here. 5 times negative 1/5. Well, 5 and 5 cancel, and I'm left with negative 1. So 5, that's supposed to be an equal. 5 times negative 1/5 is just negative 1. The denominators cancel. That's why I did that. Now over here, on this side of the equation, I still have my equal sign. I could go 5 times 4/5. Well, the 5's cancel, and I'm left with 4. And bam, no more denominators. Multiply both sides of the equation by the common denominator, and you get rid of your denominators. Okay, now I can go ahead and solve this. Add 1 to both sides. I get 25r equals 5. Now divide both sides by 25. I'm going to get r equals 5 over 25. Well, this fraction reduces. 5 goes into 5 one time, 5 goes into 25 5 times, and I get the same solution. All right, on to number 7. 3 times a number plus 12 minus 5 times the same number is 22. What is the number? Write out what you hear. 3 times a number. Well, pick what you want that number to be. You can use n for the number. You could use x. Let's use n for number. So we're going to go 3 times a number. So 3 times n, or 3n, plus 12. So plus 12 minus 5 times. So minus 5 times that same number. The number was n that we chose. Is means equals, is 22. What's the number? We'll solve it. 3n plus 12 minus 5n equals 22. We've got n's together. They're not together, but they're on one side of the equation. So before we start working both sides, let's simplify this side. 3n's minus 5n's is negative 2n's. Okay. So we've got 12 here still. Positive 12 minus 2n's equals 22. Now this is simplified as much as I can do. I want n by itself on this side of the equation, so start working both sides. To get n by itself, first peel off this. Don't peel off the negative 2. You do your division last. Peel off the negative 12. It's positive 12. Excuse me. Peel off the positive 12 by subtracting 12 to both sides. All right. By doing that, we come up with negative 2n equals 22 minus, that was a 12, minus 12 is going to give me 10. And I'm going to write it up here because I ran out of space. Negative 2n. Okay. And then the last thing is negative 2 is multiplied by n, so I divide by negative 2. Now I'm going to come up with n equals a positive divided by a negative is a negative, so I'm going to get negative 5. N is negative 5, and there you have it. On to the next one. All right, Jeremy is looking at 2 different lawn care companies to weed and mulch his flower beds. Green Care Landscape offers to charge $100 for the mulch plus $12 per hour for labor. So let's go green, G for green. This is their deal. $100 for the mulch straight up plus $12 an hour for labor. So plus $12 per hour. So H will stand for how many hours it is. Now D and J Landscape, over here, these guys offer to charge $23 per hour, so times the number of hours, for the job, including the mulch. So they don't charge that extra $100 for the mulch, but they have a higher rate per hour. Okay, what's the max number of hours the job could be for this guy over here to have the better deal? So what we want to do is find out, where is it equal? Okay, where are the hours? How many hours will I work when I get the same deal from both of those? So let's go ahead and set that up. If I charge $100 plus $12 per hour, or I just do $23 per hour, where will those two be the same? How many hours will that be? Let's go ahead and solve for the hours. So we want to get the hours together on both sides of the equation. Subtract 12 hours to both sides of the equation to get the hours together, and I'm going to have 100 equals 23 hours minus 12 hours is going to be 11 hours. Now I want to solve for hours, so I have to divide both sides by 11. 11 is multiplied by hours, so divide by 11 on both sides. 100 divided by 11 is approximately 9.09. So a little more than 9 hours, and I get the same deal. So think of it like this. If I worked 1 hour, okay, if the landscapers worked 1 hour, this might be a better deal, because at 1 hour, I'm going to get charged, for 1 hour over here, I'm going to get charged $12 times an hour, so 12, plus 100. I'm going to get charged $112. 1 hour over here, I'm only going to get charged $23. Okay, if I worked 2 hours, okay, so let's go 2 hours. Over here, 2 times 12 is $24 plus 100, so I'm going to get charged $124. Over here, if I do 23 times 2, I'm going to get, what is that? $46. So that's much cheaper. Okay, so 3 hours. If I go 12 times 3, I'm going to get 36 and then add 100. So this is going to be 136 bucks. And over here, 23 times 3 hours is only going to be $69. So if they don't work very many hours, this is the way to go. So what's going to happen? I'm going to keep doing this all the way to 9 hours. Let's see what happens at 9 hours. When I go 12 times 9, I'm going to get 108 plus 100. That's going to be $208. If I do 23 times 9 hours, I'm going to get $207. So still at 9 hours, it's $1 cheaper over here. Anything over 9 hours, if I go to 10 hours, this is going to start getting cheaper. 10 times 12 is 120 plus 100 is going to be $220. Okay. 10 times 23 is $230. So this becomes more expensive than this. So at 9 hours, that's the max number of hours I can do where this is still a better deal. So at this point, where do you round up or down? You round down, because it says what's the max number of hours the job could be for D and J to have a better deal. At 9 hours, it's $1 cheaper. At 10 hours, that's when it starts getting more expensive. So we're going to say at 9 hours. All right. Let's do some more solving. We've got to get our m's together. So let's get them together. we want to pull both m's to the same side. So it doesn't matter which way you go. Maybe I would add 2 m's to this side because I like my variables to be positive. Okay. By doing that, I do bring this down, I get 13. There's the equal sign. 2m and 2m is 4m's minus 3, bring everything down. Now, excuse me, m is still not by itself, so I got to get rid of this 3. Peel off the multiplication, or excuse me, the addition and subtraction before you do this division. So add 3 to both sides. Then I'm going to get 16 equals 4m. Now my last step is 4 is multiplied by m, so divide both sides by 4. Opposite of multiplication is division, and I'm going to get m equals 4, and you're finished. Let's go to number 10. In order to solve this, first I want to undo these parentheses. So let's go ahead and use distributive property. This negative can be thought of like a -1. You can say -1 times 3, -1 times -15, or just think distribute the negative. Negative times 3 is -3b. Negative and a negative make a positive 15. Okay. Distribute the 6. 6 times 2b is 12b's. 6 times 5 is positive 30. Now you've done this, you've got to get your b's together and your constants together. So my choice would be to move these b's over here because I like my b's to be positive. So I'm going to add 3 b's to both sides. All right, and I've got 15 equals 12 b's plus 3 b's. 15 b's plus 30. Bring everything down. Okay, now let's peel this part off. This is a multiplication right here. We're going to save that for last. We have to divide, and we don't want to have to divide by this. So let's peel that off first. Subtract 30 over to both sides, and that's going to leave me with 15 minus 30, which is -15. Bring down the 15. Now this is a multiplication, and to get rid of it, we divide by 15 on both sides. -15 divided by 15 is -1 equals b. And I've solved it. You can always check by plugging in -1 for b in both sides and making sure those are equal. That's a good way to check. All right, on to number 11. Let's look at 11. Let's go ahead and solve this. Use distributive property first. You want to get rid of parentheses first. So simplify both sides before you start working. Simplify one side before you start working on both sides. So -5 times x is -5x. And then -5 times 7 is -35. All right, so that's that side. Let's go ahead and rewrite this side. Let's see, is there anything we can do over here? No. So let's go ahead and start getting the x's together. Okay, if I get the x's together, I'm going to go ahead and add 5x to this side. Now I can already see something weird's going to happen. When I do that, that eliminates this, and -5x's and 5x's, well, they fall out and they go to 0. Well, that's weird. Now I have no more x's. Now I bring down the -35, and I bring down the equal, and I bring down this 35. Now 2 things happen when I have no more x's. I can either have all real numbers or I can have no solution. Now this case is going to be a no solution case because look at what I've got. -35 equals 35. When does that happen? -35 does not equal 35. They are not the same number. This guy's negative, this guy's positive. This is no solution. There is no x I can put in here that will make these two equal to each other. There's no x I can put in here that will make these two equal each other. Now, had I came up with the solution, +35 equals +35, my solution would be all real numbers, because no matter what I put in for x, these would always be equal. 35 would always equal 35, but that's not the case, okay? These do not equal each other. This is no solution. Okay, let's go on to solve for p. This is where you're solving for a variable and you're not necessarily getting a numerical answer. This is great for formulas that you'll use for chemistry, that you use to get, like, for example, changing from Celsius to Fahrenheit. That's a super common one. If you have anybody that's not from the US, from Canada, for example, they're going to think all weather in Celsius and not in Fahrenheit. All right, so let's look at this. Solving for P, we want this guy. So in order to do that, we're going to peel off everything else. This is all divided by J, all of it, not just a part of it. So let's peel off that first and multiply both sides by J. Okay, and by doing that, the J falls out on this side, and over here I've got J times N. So I'm going to go Jn equals P minus K. Now my goal is to get P by itself. So K is subtracted from P, so I do the opposite and I add K. So I've got J times N plus K over here, so Jn plus K. Bring down the equals, and over here I just have P, and now I've solved for P. This can't be simplified anymore. You're finished. Easy as that. Okay, let's go on to number 13. Dan drove 512 miles in 8 hours. What is his average speed for the trip? Remember, speed is in miles per hour. Okay, miles per hour. In the miles per hour. That's how you tell speed. All right. If Dan drove 512 miles in 8 hours, you're going to go 512 miles divided by 8 hours. That's going to give you miles per hour. Okay, so go ahead and do that division. 512 divided by 8, and it's going to give you 64 miles per hour. And you're finished. That's also going to be your rate. And oftentimes, instead of miles per hour, we rate it like this, 64 miles per hour. That's how you'll oftentimes see it. But it is miles per hour. Okay, okay guys. Looking at this one, an athletic director is laying out a rectangular soccer field to be 60 meters wide and 95 meters long, like I've drawn here. Okay. What are the dimensions of the field to the nearest whole yard? Now, if you don't know conversions from meters to yards, just go Google that, because you do have to do the conversions here. So if you Google, depending on which way you Google, 1.04 yards is 1 meter, or 1 yard is 0.914 meters, and you can see both of these are close to 1 because a yardstick is about the same length as a meter stick. Okay, so if I'm changing 60 meters, let's use this conversion. I did 60 meters times 1.094 yards over 1 meter. Now I'm going to do an approximation here because they're decimals. Okay, it's not going to be exact. The meters cancel out. That's how you know the meters need to go on top here. You want the meters to cancel out because you're converting to yards. Okay, so one should be on top and the one should be on bottom. So you have meters that will cancel out. So if I go ahead and go 60 times 1.04, I'm going to get approximately 65.64 or about 66 yards. Okay. Now, so this will be about 66 yards. And then the 95 meters, I'm going to multiply that way, 1.04 yards over 1 meter. The meters fall out, and I'm going to go 95 times 1.094, and I'm going to get approximately 104 rounded, 104 yards. So instead of 95 meters, it's about 104 yards. Okay, it just cut the rest of that off. Okay, so I believe we had 60 meters and then 95 meters, and we changed the 60 meters to 66 yards, and then 95 meters we changed to 104 yards. So this will be 66 yards by 104 yards. All right, and careful if you ever have to do a dimension where you find the area, always do your conversions before you multiply to find the area, because a meter to a yard is not the same as meter squared to yard squared. You'd have to multiply that out and double it. All right, not double it, excuse me, square it. Which is longer? Let's see number 15. Which is longer, 5 miles or 10 kilometers? Well, we have to figure out miles to kilometers. That's another one you need to look up. If you don't know how many miles are in a kilometer or how many kilometers are in a mile, if you look this up, 1.6 kilometers is about 1 mile. And if you're a cross-country runner, you know like a 5K is 3.1 miles about. That's how I remember because I ran the 5Ks. All right, so 1.6 kilometers is about 1 mile. So which is longer, 5 miles or 10 kilometers? Well, go ahead and do the conversion. Multiply this by 5 miles. The miles fall out, and you're going to go 1.6 times 5. So if I do 1.6 on a calculator times 5, I'm going to get approximately 8 kilometers. Okay, so 5 miles is about 8 kilometers. So which is longer, 5 miles or 10 kilometers? Well, 10 kilometers is going to be longer. Okay. A 10K, if you've ever done like a race, a 10K is about 6.2 miles. So 6.2 miles is going to be more than 5 miles. All right, on to the next one. Okay, when you've got two fractions equal to each other, you use the simple method of cross multiplying. Now, if this was like plus n over 7 and it was a whole nother fraction on one side, you wouldn't be able to do that. You would have to multiply both by the common denominator. But here I have a fraction equal to a fraction, so cross multiply. So I'm going to cross 4 times 7, and that's going to equal 6 times n. And solve that. 4 times 7 is 28. That equals 6n. And then your last step is to divide both sides by 6. And if I divide 28 by 6, you can reduce this fraction. It's not going to be an exact amount. If I divide 28 by 6, I'm going to get approximately like 4.66 or 4.67 if I did this on a calculator. If you want to reduce the fraction, let's see, 2 goes into 28 both times, and then 2 goes into 6, so it would be 14 over 3. 2 goes into 28 14 times. 2 goes into 6 3 times. So 14 over 3 would also be a valid answer, or 4.67. All right, on to the next one. Once again, fraction equal to a fraction. Great, cross multiply. So I'm going to have 11 times p plus 1 equals 6 times 6. Now the biggest mistake I see on this one, guys, is I see everybody go 11 times p, and they don't realize it's 11 times this whole quantity p plus 1. This has to be in parentheses. It's not 11 times p, it's 11 times p plus 1. You have to distribute. So you're going to go 11p and then 11 times 1, which will be plus 11. And then 6 times 6 is 36. Subtract 11 to both sides. You're going to get 11p equals 25. Divide both sides by 11. And then you're going to get p equals 25 over 11. If you want to go ahead and divide that out, it's going to be like 2.27 about. That's an approximation. Or you can leave it as 25 over 11. Either way, but please be careful. This is multiplied by both these terms. Make sure you distribute. All right, Jennifer's ordering cake for a wedding reception. If one cake will feed 18 people, how many cakes does she need in order to feed 150 people? Well, if one cake feeds 18 people, how many cakes to feed 150 people? We'll multiply that ratio by 150 people. The peoples fall out, and you're going to have one cake times 150 over 18. So really, you're just going to go 150 people divided by 18. So if I do 150 and divide that by 18, I'm going to get approximately 8.3 repeating cakes. So how many cakes does she need? Well, you don't want too little cake, so you're going to round that up to 9 cakes. You don't want 8 cakes because it wouldn't be quite enough. So round that up to 9 cakes. And that's how many you would need. All right, let's look at number 19. On the football team, 2 out of every 7 players are seniors. If the team has 84 players, how many of the players are not seniors? Ooh, the not part is confusing. Okay, let's be careful of this not part. And let's look. If 2 out of every 7 players are seniors, so 2 seniors out of 7 players, okay. If the team has 84 players, how many are not seniors? Well, if 2 out of every 7 are seniors, how many are not seniors? That's what we actually want to know. What's the ratio? Well, if 2 out of every 7 are seniors, we're going to find how many are left. 7 minus 2 is 5. There's 5 that are not seniors. 5 not seniors out of 7 players. This is the ratio we actually care about because that's what we're looking for, not seniors. So 5 not seniors out of 7 players is our ratio. So we can go 5 not seniors, okay, we'll call them 5 nots, out of 7 players, and then multiply it by 84 players. Okay, the players fall out, and we're going to go 5 not seniors times 84, so multiply the top, 84 times 5, and that's going to be what? 420. 420 over, and that will be the knots, over 7. So we're going to go 420 and divide that by 7, and you're going to end up with 60 not seniors. So 60 not seniors out of 84 players. Now another way that you could have set this up is you could have gone, let's see, first figure out the not seniors to players. So 5 not seniors to 7 players, okay? Set it up like a ratio. That would equal how many not seniors to 84 players, okay? So you would cross multiply here. You would go 5 times 84, and you would get 420. Multiply these. And then cross multiply this way. You go 7 players times x, or 7 times x. Then solve for x and divide both sides by 7, and you would end up with 60 equals x, which is the same solution we ended up when we did just our ratio times the number of players. You could set it up set up an equivalent ratio. 5 not players to 7 players is how many not players to 84 players? I mean, how many not seniors? I said players. I meant seniors. Sorry. All right, that's how you do that one. 60 not seniors are players, actually. Okay, let's go ahead and solve these inequalities. Careful with the inequalities. The only thing you need to be careful is if you multiply, let's do multiply or divide by a negative, then you flip the sign. Okay, make sure if you multiply or divide both sides by a negative, you flip the sign. That's the only difference between solving inequalities and equations, besides the graphing, of course. Okay, this doesn't ask you to graph. The solutions give you a graph. I'll take either. Let's go ahead and solve this. Just like an equation, distribute. 3 times 2c is 6c. 3 times negative 2 is negative 6. Minus 2c is greater than 0. Okay, so now on this side of the inequality, I still, just like an equation, I need to get my like terms together. I'm not working both sides yet. So I have 6c's minus 2c's give me 4c's. Minus 6 is greater than 0. Now I want the c by itself, so I'm going to add 6 to both sides. Now I'm not multiplying or dividing by a negative. I'm adding, so I don't do anything to my sign, just leave it. And I come up with 4c's is greater than, on this side I have 6. Now I'm going to divide both sides by 4. I am dividing on both sides, but I'm not dividing by a negative. So I'm going to come up with c is greater than 6 over 4, which can be reduced to 3/2 or 1.5. And that will be your solution. If you'd like to graph it, it might look something like this. 0, sorry, that's a 0. 1, 2, 3. This is about, our 3/2 is 1.5, so right about here. It's a greater than, not greater than or equal to, so I do an open circle at 1.5, and C is greater than, so it would go this way. That's what the graph would look like. All right, on to this one. Let's go ahead and solve this one. Let's use distributive property first to simplify this side. So 4 times r is 4r, then 4 times -2 is -8. Bring down everything else. -3r plus 15 is greater than or equal to 4r minus 8. Go ahead and finish solving by getting your r's together on both sides of the inequality. So I'm going to go ahead and add 3 r's to over here, plus 3 r's. All right. That eliminates that. I've got 15 is greater than 4 r's plus 3 r's are 7 r's minus 8. Now I'm going to add 8 to this side. Okay, add 8 to this side. And that eliminates that. And bring everything down. 15 and 8 is 23. It's greater than 7r. And now go ahead and solve. I'm going to divide both sides by 7. I did not divide by a negative, so I do not flip the sign. 23 over 7 is greater than or equal to r. If you want to convert that to a decimal and round, that is fine, and that's your solution. Okay. Now there are going to be solutions where you'll have no solution, and something like that might be this scenario. Hold on. Okay, just remember from the textbook, if you come up with something in an inequality just like an equation, that's always true. So in an equation you would come up with like 25 equals 25. This is always true, so your solution would be all real numbers. If you come up with 25 equals 15, well, that's never true, so your solution would be no solution. Now inequalities are a little different. If I come up with something like this, 3 is greater than 2, or greater than or equal to 2, either case, 3 is always greater than or equal to 2. This is always true, so the solution would be all real numbers. So no matter what I put in for r, this would be always true. That's not true for this particular problem, but for example, okay? Now if I came up with something like this, 3 is less than 2. When is 3 less than 2? It's never less than true. That would be like this scenario. This would be no solution. Okay, so it works for inequalities too. Be careful with those all solution, no solution cases. Okay, all right, let's go to this inequality. This one, you got this in the middle, so you can solve this 2 ways. Let me show you the first way that you could solve this, and I'm just going to scroll up a bit so that we have some space. Hold up. Okay, so the first way that I would solve this, and this would be the easiest way, just make sure you're getting y in the middle of this inequality by itself. So you're like solving 2 inequalities at once. So to get y by itself, you would get rid of this 2. So I'd subtract 2, but since I'm doing 2 inequalities at the same time, I subtract it to all the sides. I'd minus 2 here and minus 2 here. I'm like solving 2 inequalities at the same time. This side and this side. That eliminates the 2. I bring down the y. I bring down the less than or greater than sign, and -2 minus 2, or excuse me, -4 minus 2 is -6 on this side. Now on this side I have -10, I have the greater than sign. -10 minus 2 is -12. Now I've solved it. Okay, so y is less than -6, and y is greater than -12. So on a number line, that would look like this. Here's -6. I'm going to put an open circle because it's not less than or equal to, it's just less than. And here's -12. I'm going to put an open circle there. Y is greater than -12, so I would go this way on the number line. And my arrow would go forever this way. Y is less than -6. Since y is less than -6 is greater, I would go in the negative direction. It's less than. And what I would cover is this section in between. Okay? So this would be an and type statement. Okay, an and. Now the other way to solve this is to separate this into two inequalities. You would go -4 is greater than y plus 2 and y plus 2 is greater than -10, and solve these separately. Okay, so subtract 2 to both sides and you would get -6 is greater than y, which is this part, and subtract 2 to both sides and you would get y is greater than -12, which is this part. Okay, so y is less than -6, we did that this way. Y is greater than -12, we did that this way, and we come up with the same graph. So you could separate it or you could solve it at the same time. Now let's look at this OR scenario. Now usually ands go together and usually ORs go apart in your graphs. On occasion the ORs can overlap, but let's go ahead and look at this. Here's an OR one, so we're going to solve this side first. Let's go ahead and solve this side. We're going to subtract 5 from both sides so that I can isolate the m. So by subtracting 5 to both sides, that eliminates the 5, and I get -m. I bring down the less than. Ooh, that's an m. And then 4 minus 5 is -1. Now I need m to be by itself. So -m is like -1 times m. So in order to get rid of that negative, I have two choices. I could either multiply both sides by -1 or divide both sides by -1. It doesn't matter. Let's do a divide. Now careful, this should be a red flag. I'm dividing both sides by a negative. Okay, that eliminates that. And when I do that, I immediately should flip this sign. I divide by a negative, I have to flip the sign. I come up with m is greater than, a negative divided by a negative is a positive. M is greater than 1. Now careful, make sure multiply or divide by a negative with the inequalities. You flip the sign, okay? Because negative and a negative go different directions. When you are changing from a negative to a positive, you change the direction that you're going with an inequality. It's different than with an equal sign. So please be careful. That's the only difference from solving equations and inequalities is that multiplication or division by a negative. Flip the sign, okay? You'll come up with the wrong solution if you don't do that. Now let's work this side, or let's work this side. 7m is greater than 35. So to solve both sides, I'm going to divide by 7. I am not dividing by a negative number, so I do not flip my sign. I keep it the same. M is greater than 35 divided by 7 is 5. So m is greater than 5. So I have an OR scenario, but this is a strange OR. Usually they go apart. This OR actually covers itself. Okay, if I were to draw this, this is 0. Here's 1. Here's 2, here's 3, here's 4, here's 5. I want m is greater than 1, so I put an open circle at 1 and I want everything bigger than it. And here I want m is greater than 5, so I put an open circle on 5 and I want everything is bigger than it. This actually covers both scenarios. M is greater than 1 covers m is greater than 5. And that's why you only see one solution. You see m is greater than 1 because it covers this. Usually with the ORs, you would have one going this way and one going this way. But this is a special OR scenario. All right? And if you just have this as the solution because it covers both terms, it's correct. If you put both of them, also keep it. Okay, let's look at absolute values. With absolute value equations and inequalities, remember you have two scenarios with absolute values. Okay, you have the positive case and the negative case. Now this is a special case. I have -2 equal to the absolute value of this. Now when I take the absolute value tells you distance from 0 on a number line. Distance from 0 on a number line, distance can never be negative. Never, never, never. So when I take the absolute value of something, I get a positive number. How could I take the absolute value of this blob and have it equal to a negative number? I don't even have to work this problem. I already know it has no solution. Okay? Be very careful with that. No solution on that. Now I'm going to just show you real quick. If this were 2 equals m minus 1/5. Now I could solve this, okay? If I were to solve this, I would have two cases, okay? Positive case would be 2 equals m minus 1/5. And the negative case, okay, the negative case would be -2 equals m minus 1/5. And I would solve both of these cases, okay? I would solve this case and this case. So remember, absolute values have two cases. They have the positive case and the negative case. Solve both cases. Now, that is not the case in this one. I don't even have to solve because absolute values don't equal negative numbers. I have no solution. I'm just showing you if it did have a solution, if that were positive, I would set up two cases. Real quick, just to go over this because I get this question a lot. Remember, absolute value represents distance from 0 on the number line. So if I say the absolute value of x equals to 5, and I were on a number line, I would have the choice of going 1, 2, 3, 4, 5 in this direction, or 1, 2, 3, 4, 5 in this direction, okay? So that x value could have been 5, the absolute value of 5 is equal to 5, or that x value could have been -5, because the absolute value of -5 is also 5. The distance from 0 this way is 5. The distance from 0 this way is 5, okay? So the value could have been 5 or -5. So when I'm solving for this, that's why I have the two cases, right? It still is always positive, but this could have been x equals to 5. Or the negative case could have been x equals to -5. So I get that a lot, even though I just said it can't equal to a negative because the solution can't equal to a negative. But the original problem, it shows both the positive and the negative case. When you're setting up the problem to solve, you have to set up both sides, okay? So let's do that here. P plus 3, the absolute value of it is going to be greater than or equal to 10, okay? So solving this, I'm going to set up the positive case. P plus 3, so drop the absolute value bars, set up the positive case, is greater than or equal to 10. Now set up the negative case. Now careful with the negative case, when you're dealing with inequalities, you have to flip the sign. Okay, flip sign. Okay, flip the inequality the other way. So you're going to make sure you go P plus 3. Instead of greater than or equal to, you're going to go less than or equal to -10. Remember flipping the sign when you're multiplying or dividing by a negative. It's the same thing when you do the negative case with the absolute value. All right. Solve this side. Subtract 3 to both sides. You're going to get P is greater than or equal to 10 minus 3, which is 7. Okay, there's that side. Solve this side. You're going to subtract 3 from both sides. And you're going to come up with P is less than or equal to -10 minus 3 is -13. Okay, and there's your or. It's one or the other. And if I looked at this on a number line, it would look something like this. And hold on, I'll just draw. All right, on a number line, P is greater than or equal to 7. So here's 7. Greater than or equal to would mean a closed circle at 7. And I want to go greater than, so I'm going to go bigger than. It would be this way. In this one, P is less than or equal to -13. I'm going to come to -13. Whoops, that should be a negative because it's below the 0 sign, the 0 value. And I'm going to put a closed circle at -13, and I'm going to go less than it. So I'm going to go this way. And that's how you solve that. So remember, both with absolute values, you have two cases, the positive case and the negative case. And with the inequality, make sure the negative case, you flip the sign when you write the negative case out. Then solve it. You should have two solutions. And that's how you do this. Good luck. Email me if you have any questions. Come to my open tutoring hours. Have a good day.